So what we do in this particular class will be at very high level. We will see what data science is, why it is important, and also what are the specific technologies or tools that we are going to use as part of this entire course. Yeah, so today will be primarily about understanding the field of data science and understand the basics and the components within data science. Okay, and of course, as we discuss data science, we'll also try to understand what a data scientist is supposed to do. Okay, the responsibilities of a data scientist and what are the expectations from him. Okay, and finally we will. So as I mentioned in the beginning, in this particular course, we are going to touch base on multiple softwares. The primary one being R, and next is the Hadoop, and then Mahout. Okay, so these are the three things that we are kind of going to use in terms of the softwares in order to put our concepts into practice. Okay, so I'll give you a brief introduction on Hadoop and R, and why. More than the introduction, I would like to discuss why they became so famous all of a sudden. Okay. And also we'll talk about R and Hadoop integration at very high level, of course. We will have a separate class on doing that, and also understanding how we can do machine learning using Mahout. Okay, as probably each of you heard about the word data scientist. It's a new hot field in the market, and as some people mention, it's the sexiest job of 21st century. Okay, even though it's sexiest and hottest and stuff, not many people really know what exactly a scientist should do. Okay, and even the industry itself is trying to figure out what the specific roles of a data scientist as it is getting mature. Okay, we will see what are the different flavors of data scientist roles. Okay, okay. Finally, we come to data science. Actually, we already talked about data science without calling it a data science. Like we talked about recommendations. Okay, that's data science, and we talked about like creating coupons or something like that. That's another form of data science. So data science is essentially understanding data and building necessary mathematical models in order to kind of do some classifications or predictions. Okay. For example, in financial domain, whenever a transaction comes into your system, you need to first analyze it and say and classify whether it's fraudulent or not fraudulent. And if it is fraudulent, you want to flag it up. You want to flag it and contact the customer and whatever you want to do, right? So the classification of fraudulent versus non-fraudulent is a machine learning problem, and it's a data science problem. Okay, and similarly, we have emails. Every one of us have emails. And there is also notion of spam messages, right? So back in the days, those spam messages used to come into our inbox, whether it's some African person, Nigerian person trying to make some transaction or some other thing. There's so many spam messages that we have seen, right? They used to come in our inbox. But as spam filters became more and more mature, we hardly see spam in our inbox nowadays. Actually, sometimes even the useful messages will go into inbox. That's another extreme. But the point is these spam filters are essentially doing machine learning, which is again like a data science, right? You are analyzing all the emails from all the people everywhere in that particular company, and you are classifying whether a particular email is spam or not spam. Okay, that's a classification problem, which is again relevant to data science. So, so given all these examples, you can kind of see what data science is, right? Essentially, data science is about understanding data and extracting meaningful and actionable data, information from that raw data sets. Okay. And even for data science, you can kind of come up with many examples, right? Take Google, for example. We use it every day. And what is Google essentially? You type in a search query in a basic terms. You type in a search query and you get relevant results back. Okay. Do you think it is data science? Right. And so if you think about it, I mean, back in the days when Google first started, even before Google, there was a search engine called Alta Vista, right? I don't know if you guys heard about it. I'm sure some of you heard about it. So when Alta Vista was there, which is actually the first search engine in the internet space, what they did, they simply indexed each web page. Okay, if I have 10 different web pages in my system, I simply index the terms. So the term sales appear in my document 1, document 5, and document 10, and sign and the another term, let's say BJP, appears in document 5 and document 7. Okay, they're simply indexed, and depending on the query, they simply looked at in which of the documents the word occurred, the query word, and then simply retrieved those documents. Okay, that was a search engine that they had. But then after that, these two people came along, Sergey Brin and Larry Page. They said, okay, search is not just that. Actually, there's something more to it. Okay. Not just the content, but also the link information between the pages also makes sense. Okay, that's their observation about the data. So the intuition is that if many web pages are pointing to a particular web page, then probably that the pointed web page is probably important, and that's why they are all referring to it. Okay. So that means the link structure is also kind of giving you some relevant information in deciding which page is kind of more useful for a particular query than the other. Okay. And around this intuition, they built something called as PageRank, and then they use that page ranking mechanism to kind of rank different web pages in the system. Okay, that's essentially data science, because you're analyzing the data in order to get a meaningful information of different ranking, and you're able to act upon that meaningful information by showing the results in a rank ordered manner. Okay, that's actually a perfect example of a data science, even though it's not called as data science back then, but it is exactly data science. Okay, so whatever Amazon did again in 90s, when they built Amazon.com and built a recommendation engine, that's also exactly data science, even though it's not called as data science. So data science is not something new that came up out of the blue. It's just there, but people have given a sexy name to it. That's all. Okay. So yeah, that's what I mean. That's all part of data science. Essentially, you're trying to extract meaningful and actionable information from the data. Okay, and obviously, as the big data is there, in terms of volume, variety, and velocity, the challenge is to create a big data solution that can kind of facilitate this data science. Okay, if you have lots of data, obviously you need systems to store, manage, and analyze it. Or if you have, let's say, Twitter, then there the data science challenge is to how do I do analysis in that very, very fast-paced manner. Okay, and similarly, if you have variety of the data, then your data science challenge is to how do I extract meaningful information from these diverse formats of the data and then make some conclusions. Okay, Atul, I will be getting into R very shortly, but it's just not R basics. It's to just understand what R is and stuff like that at a very high level. So even if you miss, it's okay. You can always go through the video later on. And in the next class, which is tomorrow's class, we are going to spend completely our time on R. Okay, so yeah, if you have any urgent matter to attend, please go ahead and we'll meet tomorrow. Okay, great. Bye, good to have you. Okay, and so if you remember in the initial when the class just started, I told no one knows what exactly a data scientist is supposed to do, right? And this is exactly why I said that, because data science has flavors of multiple components. Okay, it has flavors of statistics, it has flavors of data engineering, it has flavors of visualization and advanced computing, and it also has flavors of the domain expertise. Okay, so depending on where you fit, the role of a data scientist can be completely different. Okay, if you are a statistician, your role as a data scientist may be different from a person who has data engineering background, which is more like the back-end processing. Okay, just to kind of give you more intuition on that aspect. So someone, I think some CEO of some Web 2.0 company mentioned that data scientist role is like the webmaster role in the 90s, okay, when the internet just started coming. Okay, back then when the internet is just coming up, people are new to web services, right? Every company is trying to devise some web or design some kind of a web service that is useful for their customers. Okay, but they didn't have a clue as to how to build such a web service. Okay, and that's where they created the role of webmaster, okay, or web administrator, and that web administrator is supposed to solve all the problems related to designing web services, whether it's a front end or whether it's a back end or the communication between the front end and the back end. Okay, web administrator is supposed to understand all of that. So webmaster was the magic bullet for solving all the problems related to designing web services. And over the time, obviously that's not the right way to operate, and over the time, as people understood more about the web services, there are different roles carved out within the space, right? There are like front-end engineers who design UIs, and there are like network engineers who design the network backend for communicating between the front end and the back end. And there is also like database specialists, or depending on what backend they use, there are specific people who manage the backend. Okay, and similarly, fast forward 20 years or 15 years, and now we suddenly have this new role of data scientist. Okay, and just like the webmaster in 90s, data scientist is supposed to understand everything about the data. Not just understand, deal with every challenge that we discussed about the data. Okay, like he should understand, at least that's the expectation of data scientist as of today. He's supposed to understand how the data is stored in the backend, how do we manage it in a Hadoop cluster, and then how do we analyze using machine learning statistics, and ultimately how do I visualize so that I can present it to my top level management. Okay, so all these aspects are expected to be understood by a data scientist. Okay, so he's like the jack of all trades. But over the time, as the data science field gets more and more mature, probably there will be different roles carved out within this particular data science field. Okay, but the point that I'm trying to make is data science is essentially a confluence of many components, and as of today, we don't have a clue what exactly the role of data scientist should be. So if you are trying to enter data scientist today, then I strongly recommend you to kind of get some knowledge from each of these components. Okay, if you are already working in, let's say, data warehousing, then you know about data engineering and some bit about advanced computing. Then you will go ahead and learn a little bit more about the statistics and machine learning and maybe some visualization. Okay, or if you are working as a let's say BI person who creates reports, who visualizes reports every day in, day out, then you want to get some knowledge about data engineering, which is the back-end processing, as well as some statistics. Okay, or if you are a machine learning expert or a core mathematical statistician, then you need to understand, or you need to learn about system aspects like data engineering and advanced computing. Okay, or if you are a domain expertise, which is like a functional person, then you need to understand all these other components in order to become a good data scientist. Okay, so that's why I said if you want to enter the field of data science as of today, then it's a good idea to kind of get some exposure in each of these components. Okay, does that make sense? Exactly. Aruna says, I believe it is unrealistic to have one person called data scientist with all the attributes. That's absolutely true, but that's what you expect. If you see any data scientist role job posting, you will have a lot of these things, right? You are supposed to understand the Hadoop platform, Cassandra, or whatever that is of their interest, which is related to data engineering and advanced computing. And also they'll say, oh, you need to understand classification models or recommendation engines and stuff like that, which is about statistics. And depending on the company, they might also ask you about visualization aspect as well. Okay, but I understand totally your point is absolutely valid, and probably over the time we will figure out what the individual roles are going to be. Exactly, Aruna, and as you're saying, so she says that data science, so I can understand data science team which has group of people with different attributes to fulfill the requirement. Absolutely. Hopefully that's how it's going to be in the future. And if you look at like big companies like Google and IBM or Facebook, all these companies actually hire a lot of people, right? Google hire economists, Google hires sociologists. So these are all like different people, expertise in different backgrounds, and hopefully they I mean, I don't know inside Google, but I hope they're all working together to solve the issues, right? So Arun says how the data science career would be for a non-data science expert. Okay. I don't know how to answer that question. So what do you mean by how the career would be? So as I mentioned, depending on which of these components that you're currently working in, it's a good idea to kind of get exposure of the other components. But otherwise, I don't really understand the specific question. Maybe you can expand on that question, or if you want, I can unmute you and you can speak, and then we can discuss. Okay. So those are different components of data science, and this is just a graph showing the job trends about data science. That's fine. So these are the types of data scientists that I was talking about. Depending on which component you are expertise in, the type of role that you may get may be quite slightly different. Okay. Shashank says, for data visualization, which tools do you think one can get exposure to? There are multiple of them. Like R itself has a lot of plotting and charting capabilities, and there are newer things like Tableau, which can do better visualizations than R. Exactly, like Aruna says, Tableau is used very popularly nowadays. Okay, Niranjan says predictive analysis versus machine learning. I think it is overlapping. Where is the difference? Can you please explain? Very good question. As you said, predictive analysis and machine learning are overlapping, and I would even say they are subset essentially. So predictive analysis is just one branch of machine learning technique. Okay, and there are other classes of machine learning techniques around, let's say, clustering and other things, which do not form predictive modeling. Okay, so predictive modeling or predictive analysis is a subset of machine learning techniques. Yes, and Aruna puts it in another way, which is absolutely right, is machine learning helps to do predictive analytics. Okay, this is again different roles and the focus of those roles. Okay, like if I'm a data researcher, for example, the focus of my work would be primarily on doing machine learning and statistics and necessary math behind it. Whereas if I'm a business person, if I'm a data business person, I'd be spending more time on the business aspects of it, which is probably dealing with a lot of domain expertise. Okay. Yeah, we talked about all this. It's essentially all those components kind of slab them under these three bullets, which are data architecture, machine learning, and analytics. Okay, and for data architecture, we will be dealing with Hadoop in this particular class, primarily because Hadoop is now becoming a de facto standard for big data analysis because of its simplicity and resilience and other features. And for machine learning, we are going to deal with a particular tool called Mahout within Hadoop ecosystem. But I mean, more than tools, for machine learning, we will be learning a lot of concepts. Okay, so we will learn a lot of concepts which are independent of the specific technology that is in place. Okay, whether it's SAS, whether it's R, whether it's Mahout. These concepts are still valid, and you can apply to your real-world problems. Okay, so the lot of emphasis will be on learning those concepts. Okay, and for analytics, we are going to use R as a primary tool. Okay, so we have looked at use cases. So okay, yeah, this one kind of tells you what is the process flow of data scientist in dealing with any particular problem, right? So let's go over them quickly, and probably we can understand that flow in a better manner. Okay, so the first thing that you would, given a data set and given a problem, the first thing that you would do is understanding the problem statement and defining the solution space. Okay, what consists of that solution? Like if it's a email classification problem, then your solution is in building classification model. Okay, and that basically predicts whether something is spam or not spam. Okay, if your problem is, let's say, doing market segmentation, then your solution space is not a classification model, but instead a clustering technique that you would develop in order to kind of divide your customer base into different segments. Okay, and depending on that solution space, you understand which machine learning algorithm to be used in that particular analysis. Okay, and once you decide on one algorithm or a bunch of algorithms, then you implement those algorithms on a smaller data set. Okay, you don't directly go to a bigger data set. You may be working on a sample of the data set or other smaller subsets. We will see later when we look at individual techniques how those subsets can be computed. But the point is, you apply those algorithms on a smaller data set, maybe using tools like R, MATLAB, SAS, whatever that is. Okay, and then once you gain enough knowledge and once you convince yourself that this model is good enough to solve your problem in hand, then you go and apply your model or implement your model on the big data. And when you're doing that, you use tools like Hadoop and Mahout, okay, or R and Hadoop in conjunction. And through this, you kind of explore different ways in processing the data on that big data sets. And then finally, you visualize your results and maybe plot some charts for your management to look at and so on. Okay. Exactly. Aruna, that's true. So she says, don't we want to understand the data available before doing machine learning? Absolutely true. And that's actually, I would say, put it in the first bullet of understanding the problem statement. Also say explore the data set to understand what the data is. That's true. So in other words, this this particular slide is slightly incomplete, but still shows the overall flow. Okay, Niranjan asks Mahout versus R, when to choose considering Hadoop is used. We'll get to that question, Niranjan. Just hold on to it. Okay, there are a bunch of use cases here. Maybe we can skip some of them, which is essentially, it's talking about the same data flow that we talked here, but instead of in this generic manner, it's talking with respect to a particular problem. Okay, so this is a domain from this data set is obtained, and this is a problem statement, and how do you go about it? Okay, what are the different steps that are involved in solving that problem? And that's essentially what this flow looks like. Okay, and similarly, market basket use case. Like if you are a grocery store or a retail company, how do you analyze your data in order to make better campaigning strategies, better product placements, better pricing strategy, and stuff like that. Okay. And we talked a lot about healthcare. You can go through these process flows. It's pretty much similar to what we just discussed at a high level. It's pretty similar to that, but focused at the specific problem that is in hand. Okay. Yeah, with all that, we already said the core components that we will deal with are primarily Hadoop, R, and other machine learning concepts in general. Okay. So let's briefly talk about these individual tools that we are going to use in this course, so that we get some basic understanding of all the components. And as I pointed out, there are a lot of material on your LMS website, which I strongly encourage you to go through so that you get more information about these tools that we are going to use. Okay. So Hadoop, I know some of you are already working on Hadoop, but some of you may have just heard what Hadoop is, or just the word Hadoop. So Hadoop is essentially a framework or an ecosystem for doing distributed data processing. Okay, it's run on top of a cluster, and cluster consists of multiple machines connected through an internetwork like Ethernet or InfiniBand or any other network. And your data is distributed across these different machines, and Hadoop is a framework that kind of manages that data distribution, as well as gives you a programming model through which you can interact with those data sets. Okay, and this is an open source project which is part of Apache Foundation. So you can download, anybody can download the data, download the code repository and work with it, and you can even contribute to the Apache Foundation. Okay, and it all started from a paper, research paper that was published by Google on a programming paradigm called MapReduce. I mean, the programming paradigm of MapReduce is not new. It was there well before Google published that paper. It's just that Google kind of showed very good use case of that particular programming model in solving a real world problem, okay, which dealt with lots and lots of data, not surprisingly, because it's Google, right? So that kind of opened eyes, as if you will, in basically people stood up and made notice of that particular paper. Oh, okay, this is a way we can analyze big data sets or large data sets, and that problem is kind of relevant to every industry, and therefore the entire MapReduce became so famous, and the open source initiative of Hadoop, which is primarily fueled by Yahoo, kind of resulted in what we have as Hadoop today. Okay. So it's open source, and therefore there are many distribution companies like Cloudera, Hortonworks. Actually, there are many other companies have their own distributions of Hadoop, like IBM, Oracle, and of course Cloudera and Hortonworks also have their own distributions of Hadoop. Okay. And the key characteristics of Hadoop is one, it is scalable. That means it's scalable to large data sets and large clusters of machines, and it is reliable. That is a very, very important aspect of Hadoop, is the reliability. Meaning, so the Hadoop clusters are typically built using commodity machines, not some enterprise scale high-end machines, but instead with commodity machines. Okay, so we would be using something like our desktop or a laptop in this particular cluster. Okay, and obviously these are not meant for doing some high-scale processing, and therefore they tend to crash, right? Sometimes your memory may get burnt out, your disk may go bad, or your communication network, or meaning your Ethernet card may get conked off, or your machine itself might become highly heated because you're doing lots and lots of processing and stuff like that. There are many ways in which a particular system can crash, right? So even in the presence of those failures, the Hadoop ecosystem or the Hadoop framework is able to operate on that entire data without any loss of information. Okay, that's the reliability aspect. And that is very, very important, and it's also called as fault tolerance. That is a primary key differentiating aspect of Hadoop when compared to all the previously existing data processing architectures. Okay, so fault tolerance is very, very important, and it's economical because the clusters are built using these commodity machines as opposed to enterprise machines. For example, if you take IBM mainframe computer, for example, it costs millions of dollars, and you can't build a Hadoop cluster using those high-end machines. Okay, instead you build using smaller commodity machines, and therefore it's economical. Okay. And also it's robust, which is kind of related to reliability and fault tolerance. And it's flexible because the programming model itself is simple enough to build whatever you want on top of it. Okay, so these are the key characteristics of Hadoop. Any questions here? Okay, no questions at all? Okay, good. What is Hadoop cluster? So Hadoop cluster is essentially a cluster in which Hadoop is installed, that's all. And the cluster is essentially a bunch of machines connected by a network. Does that make sense, Saronan? Okay. So yeah, Hadoop cluster is essentially a cluster in which Hadoop is installed. Any other questions? Okay, so yeah, we don't need to go into the core components as of now. This is going a bit into the architecture, but the primary thing I would like to kind of mention in this particular slide is the two aspects of the core Hadoop. One is the HDFS cluster, which is on the bottom. So HDFS is Hadoop Distributed File System, HDFS. Okay, and that is the component which is responsible for storing your datasets. Okay, so HDFS is for the storage aspect, and the MapReduce engine, which is a data processing platform, or the data processing platform, or the programming model that Hadoop exposes. So this one is related to how you process the data, how you analyze the data, how you access the data. Okay, so HDFS is for storing the data, and MapReduce is for processing and analyzing the data. Okay, so that's the only key aspect that I would like to kind of mention in this particular slide. And we will look at the exact architecture later very briefly, but if you're interested, you should look at those background materials like the Hadoop Essentials for Data Science. That will go in detail what this architecture is and why it is used in order to analyze large amounts of data. So that's the very, very brief introduction about Hadoop. And next is R. Okay, if you're already familiar with any other analytics component like SAS and stuff, probably you know what R is, at least in terms of its capabilities. But if you're completely new, R is essentially a software for doing statistical computation as well as visualizations. Okay, so it has a graphics component as well to do the necessary visualizations, like plotting a bar chart or drawing a curve or plotting a histogram or something like that. Okay, and it is also open source, just like Hadoop. R is also open source. Anybody can download on your laptop, on your desktop. You can install, whether it's Windows or Mac or Linux, doesn't matter. R is available on all of those platforms, and yeah, you can install it and start playing with it. Okay, and it has become highly popular these days, primarily because it's open source. Okay, because it's free, and also because it is there for many years. Okay, it's at least a couple of decades since R is there in the market, and therefore it's a very, very mature product. Okay, and that's why all these big companies like Oracle, IBM, HP, EMC, all these companies are trying to kind of integrate with R. Okay, like Oracle has their own data analytic platform around Hadoop or database or anything. They want to integrate this data processing platform with R. Okay, they want to kind of enable data scientists work on these big data sets through R by integrating with their own solution. Okay, and that's the primary reason why R has gained so much traction in last 1 or 2 years. Okay, because it's open source and because all these companies have a platform to like process the big data. That means they can store and they can do some processing, but they don't have any tools for doing machine learning or statistical analysis on big data. Okay, the only thing that they have is this publicly available R or proprietary softwares like MATLAB and SAS. Okay, obviously integrating with those will be much more difficult and takes a lot of time, right? If Oracle wants to integrate with SAS, then they have to strike a deal, they have to work out the details and stuff like that. Okay, but integrating R and Hadoop or R and Hadoop based solution within Oracle, it's very easy. Everything is open source and probably readily applicable for all the customers as well. Okay, and that's the reason why R has become so famous, and it's important for you to learn R before you enter data science field. Okay, and that's primary reason why we in Edureka kind of emphasize on learning R, and therefore we spend significant amount of time in this particular course using R and working with R. Okay, in fact tomorrow's class will be completely about working in R. Essentially, what are the basics that you would require in order to program in R language. Okay, we are going to learn that in tomorrow's class. Okay, so as I said, R is open source and free, and one important aspect of R is the packaging. Okay, so it's open source, so anybody can contribute it, but the way you contribute to R is through is through packages. Okay, so each of this package is essentially like a package of routines that are used for a specific purposes. Okay, so if I am, for example, working on biological data, okay, I may have certain statistical methods or certain hypothesis tests that are more relevant in this biological data analysis. Okay, so as a biologist or biological data analyst, I take all these methods and wrap them into a package, and then contribute that package to our community. Okay, so later on, if somebody comes in and they want to do some biological data analysis, then they can use the package that I deliver and get all the statistical tests and methods that I implemented already. They can quickly use them. Okay, so you are communicating or sharing these methods through packages. And similarly, there might be some packages for doing financial data analysis, and there might be some packages for doing classification, clustering. So it's not just about the domain, but also the individual techniques. Okay, we will learn about different packages as we go through different techniques later in the classes, but the only thing that I want you to understand at this point in time is that the extensibility, meaning adding new features to the our software, is done via packages. Okay. So Niranjan says which language R is written. Interesting question. So R itself is based on a language called S, which was there before, which is an object-oriented language, and most of the R is built on top of that S language. And however, a lot of packages in R are built using C, Java, or some packages are built using R itself. Okay, so there are a mix of multiple languages in there, but the core R is primarily built using C. Okay, so you are building a language on top of a language in a way. Okay, and another very, very important characteristic of R is that it stores the data in memory. Okay, it runs on a single machine and it stores all the data in memory. Okay, so if you want to process a particular data set, the R instance that you run on your machine will read it from the disk, puts it into the memory, and then subsequently operates on that memory. Okay, so obviously that's a limitation, right? First thing, you are operating on a single node, so you cannot deal with large data sets, or you cannot do a distributed processing. And since it stores the data in memory, you are limited by the amount of main memory that is available on that particular machine. Okay, so if you have 4 gigabytes of RAM, and then probably 1 gigabyte will go for the operating system, depending on which operating system you work on. And there's some memory that needs to be allocated for all the other services that are running on your machine. And once all that memory is taken by those services and operating systems, then the remaining, let's say 2 gigabytes is available for R. Okay, and the data has to fit in memory, and therefore the largest data that you can analyze is 2 gigabytes, right? So that's the limitation. And the integration points that I was talking about, which Oracle, IBM, EMC, all these companies are trying to make in terms of integrating with R, is essentially to deal with this limitation. Okay, how can we make R work on large data sets that are sitting on many machines in the cluster. Okay, so it tries to address the problem of single machine as well as problem of storing it in main memory. Okay, and it also has advanced graphics so that you can do visualizations, and it has nice development tools including GUI, and there are a lot of other things that you can do, and you can connect to many databases or data sources so that it's easy to import and export data from your R instance into those other data sources, whether it's a relational database or a Hadoop cluster or something else. Yeah, this is just showing the popularity of R compared to other related softwares, like primarily SPSS, SAS. So SAS and SPSS are obviously proprietary. You need to pay in order to get those softwares, and SAS especially is extremely expensive than SPSS and others, whereas R is completely open source, so it's easy to kind of deal with it. Okay. If you are working in SAS already, this chart kind of shows how SAS and R are different, but I mean, we are not interested in the difference for this particular class. Primarily, R is open source, SAS is proprietary, R is on a single machine, whereas SAS can run on multiple machines, and it's not limited by the main memory and stuff like that. Okay, and finally there's R and Hadoop integration. So we said R is single node and limited by main memory, and Hadoop is a distributed data platform. So how can I combine these two, right? R is nice little language that I can do for doing my data science, and Hadoop is a very powerful platform to work on large data sets. So how can I kind of get best of both? Okay. And that's essentially R and Hadoop integration, and we are going to look at a couple of packages which enable that integration. Okay, and these packages are developed by a company called Revolution Analytics. Again, these packages are also open source, and therefore you can download and work on your Hadoop datasets using R. Okay, we are going to learn that later in classes. Okay, and yeah, in the LMS, as we saw before, there are tools or the necessary information that is available to install R on your machine. Okay, actually, before tomorrow's class, it would be very nice if you can kind of look at the module 1. Under module 1, you will see R installation instructions. So it would be really useful if you can download R and see what it is, because tomorrow we are going to kind of go over what we can do with R, and it would be nice to have you guys set up already before we start the actual R language learning. Okay, and finally, machine learning, especially using Mahout. Okay, so now I'll get to that question of Mahout and R. Okay, so Mahout is essentially a library of routines. Okay, so when Hadoop came for the first time, they came up with only this Hadoop distributed file system and the MapReduce layer on top of it in order to do the processing. Okay, now, and as the time goes by, people want to do more and more using Hadoop framework, right? People want to do machine learning. but there is no machine learning capability built into Hadoop system. Okay, so people have developed different implementations of different algorithms. Okay, like if I am a recommendation engine, I build a particular implementation to do recommendations. Okay, and I contribute that implementation to Apache Foundation through Mahout, and other people can call that implementation to have recommendation engines in their own setting. Okay, so it is a library of pre-packaged specific implementations of the algorithms. Okay, whereas R is a language. Okay, since it's a language, you can build anything that you want using different constructs in that particular language. Okay, so that's the difference between a language and a library. R is a language, Mahout is a library. So using the library, you cannot build anything that you want. You can only invoke what is available. But using a language, you can build anything that you want. Okay, so that's the key difference between Mahout and R. So does that answer your question? I think Arun asked, right? Sorry, Niranjan asked. Okay, great. Okay, we will go into later on the individual aspects of Mahout later on. So Aruna says you can use R to build. Exactly, yeah, build new techniques, if that's what you mean.